Alright, am I live? Are we live? I believe so. Hello, hello. Alright, so this is going to be pretty short, but I just very quickly want to come back to this question because I noticed something. We were just like, okay, so I coded out a slightly different solution, and it's not really that much different. Probably not at all. But we did get 100% memory usage, optimal memory usage. And we did also get optimal speed, I think. We almost got optimal speed. Here we go, yeah, we got very close to optimal speed. The reason why I wanted to do it this way is so the difference is very slight. Before we had a loop where we had the previous value was in a loop and it was a sum of multiplications. And so we're doing multiplications at each step. And then we were also in another routine creating another sum for the total. And the difference now is what I realized we could do is we could be a little bit clever and kind of interweave these two things, and so we don't have to do any multiplications. And the clever part, it's not that clever, but it's a little bit clever, is this particular sum, this sort of 0 times, we'll call it, we'll just say x1 plus, or x0. Yeah, well, yeah, well, x0 plus 1 times x1 plus 2 times x2, so on to n minus 1, xn minus 1. This particular summation, this is equal to x minus 1 plus x minus 2 plus x minus 1 plus x minus n minus 3 plus x minus n minus 2 plus x n minus 1 dot 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 to the whole sum at the bottom all the way across to x plus x of 1, x of 2, x of 3, right? And if you add, so you can add all these numbers together, this whole sum is equal to this guy, which is really interesting, really neat. And you leave off the x0, by the way, and so you can actually add all these up as you're developing this sum. You gotta add each of these intermediary steps to get you both this guy, which is what we want for our total, and then also get this guy, which is the, what do they call that? The I guess that this, I actually know it more. I don't know what it's called, but this particular sum also, we can get both of these sums kind of at the same time by just adding the intermediary steps as we build the this larger sum. So that's what we're doing here. Is we've got these temporary intermediary steps, and we're adding to get our total, and then we're adding to what we want our previous value. We're going to add those intermediary steps. So we get our total, and we get this previous to work with, and yeah, then we can use the total here as we were before. So that it's not that much more efficient, but it does make a difference. Oh, there we go. Boom. 100%. Yeah, we basically removed all the multiplications we were doing, because what we were doing we were calculating this sum directly, and we were doing all these multiplications, which you don't need to do. So we save a bunch of multiplications doing it this way. All right. Hopefully that was interesting. I don't know. I like immediately thought about it after like taking a moment to not look at the problem and lay down, and I was like, wait a minute. There's a way to make this better. There's a way to do this better. So let me go. Thank you again for watching. I do appreciate it. I will talk to you soon. Have a good rest of your day. Take care.